Okay, welcome to the third of the organic video clips that I'm putting together. This one is on ethanol, a very popular organic molecule. And the formula of ethanol is C2H5OH. And immediately you should be spotting that this is not a hydrocarbon. And the reason it's not a hydrocarbon is because a hydrocarbon only contains carbon and hydrogen. This little molecule also contains oxygen, so it's not a hydrocarbon, and it has a structure with two carbons bonded together, and then this one is bonded to an oxygen that's also bonded to a hydrogen. Now, oxygen only forms two bonds because it's in group 6 of the periodic table. Now, ethanol is an incredibly useful molecule to the human race. Not only is it found in alcoholic drinks, but it's also used as a fuel. It makes a great fuel because you've got carbon and hydrogen also with an oxygen, which promotes efficient combustion. It promotes complete combustion. So it's an absolutely terrific fuel. It burns pretty readily. And we can make it by two methods. We can either ferment sugar or we can hydrate ethene. And both these methods have advantages and disadvantages. So the fermentation of sugar, what you need to take is an aqueous solution of sugar. So let's take glucose, which is C6H12O6, and dissolve it in water. It's very important to have it dissolved in water. And then we combine that with yeast. Now there's an enzyme in yeast called zymase that helps to break our sugar down, and it breaks the sugar down. I'm just going to rub this off so we've got a bit more space. It breaks the sugar down into carbon dioxide, gas, and ethanol, C2H5OH, and as there's still water in there, it'll be aqueous there. Now this needs a little bit of balancing. We've got 6 carbons over here, and I'm going to do this very quickly, but we'll have a 2 there and a 2 there, and hopefully that's balanced. We've got 4 oxygens plus 2, 6, and the hydrogens all add up as well. So we produce carbon dioxide at the same time as making our lovely ethanol, which explains if you did a fermentation yourself at home, maybe fermenting sugar, making ginger beer, which you can make at home, that would explain why your ginger beer is naturally fizzy, because it's got carbon dioxide dissolved in the solution. Now, you need to know the conditions which this reaction would occur under. You need an aqueous solution, you need yeast, and you'd also use a temperature of about 30 to 35 degrees Celsius. You wouldn't want to go any hotter than that, and the biologists amongst you will realise that if we go any hotter than that, we start to denature the enzymes in the yeast. We start to break the enzymes, effectively fall apart, and they can't do their job anymore. So the process stops. The process also stops when you reach 15% ethanol content in the solution, because the ethanol itself starts to denature the enzymes in the yeast. It effectively kills off the yeast. So 15% is our maximum yield of ethanol that you can acquire. You may then think, well, actually, how then do I get my ethanol out of my mixture? Because it will still be mixed up with the sugar, still be mixed up with the water. Clearly, if we're using it as a fuel, we don't really want that other stuff in there. So we distill it. And if we distill the ethanol out, we can use that pure ethanol then as a fuel. So, second method we come to is the hydration of ethene. So you should know that ethene has 2 carbons. Meerkats enjoy proper banter. 2 carbons for eth, and as it's an alkene, we've got 4 hydrogens. So it's a 1 to 2 ratio, got double the number of hydrogens. Now, obviously, you see it's hydration, which implies water. Now, this process is going on at such a high temperature, which I'll come on to in a minute, that you actually use, this actually comes out as steam effectively, and you produce your ethanol and the ethanol at that temperature will also be a gas. And the conditions you use for this, and again you need to know these, 300 degrees Celsius, we have an atmosphere of 70 times atmospheric pressure, so that's 70 atms, and we use a catalyst of phosphoric acid, and you need to know those three. Now, unlike the fermentation process, this gives us a 100% yield of ethanol. So you might think, oh, this process is much better. Okay, it gives us a 100% yield of ethanol. We also don't have to stop and do a distillation at the end of the reaction. It can run continuously. But it doesn't necessarily follow that the Ething method is the best. Why is that? Well, we need to look at our raw materials. Okay, so the raw material for the first process is sugar. Okay, so it depends on raw materials. So for the first process, where the raw material is sugar, you need a ready supply of sugar, which some countries have. Okay, if you're doing this reaction in a country which has a climate which supports the growth of sugar cane and sugar beet, like Brazil, this would be a good method. Okay, if you want ethanol in a country which doesn't have a climate which supports the growth of sugar cane, then perhaps you want to look at this process here, the second process. Now, the second process uses ethene, but you have to consider where the ethene actually has come from, and the raw material of ethene is actually crude oil. So this second process is very, very suitable for countries which have a large supply of crude oil. The first process, so talk about the availability of the raw materials. You may also talk about, for the first process, the availability of land. If you're going to produce a large amount of ethanol, you need a large amount of sugar. So you need a large amount of land. You may also talk about the kind of technology involved. Producing ethanol by fermentation is fairly low tech. Okay, it's the kind of thing you can actually do on a small scale at home. Whereas this second method requires 300 degrees Celsius. It requires 70 times atmospheric pressure, which is a huge pressure. So this might not be suitable. You need to consider the pros and the cons of each method of making ethanol. Now, the second bit on the syllabus looks at the reaction of ethanol. Now, you might expect that they might talk about combustion, but really, according to the syllabus, there is actually only one reaction, and that's the dehydration of ethanol to form ethene. So it's effectively the reverse of reaction 2, which was on the first slide. So here's our ethanol, and if it's a dehydration, that means you take water out. Here's our water, and the other product you form is ethene. You reform your ethene. Now, in order to do this, okay, you need to pass your ethanol over an aluminium oxide catalyst. You also need quite a large amount of heat to do this. Okay, and this is a very popular question on the exam, to write a balanced equation for that process and to give the catalyst which is used. And that actually brings us to the end of this video clip.